lab 10 I will call fraction sum. Okay, so in this lab we're asked to add the fractions starting with 1/2, then 1/3, 1/4, all the way to 1 over 100. And the sum turns out to be about 4.187. Okay, so notice that I've removed the scanner. There's no question to ask here. We're just using these same numbers every single time. So I don't need to ask the user for anything. I'll just go ahead and write a loop. And I'll initialize this loop to begin at 2. And the reason is, if you notice these fractions, the numerator is 1 every time. So we don't need the loop to do any work there. It's just always going to be 1. The loop's role is going to be to produce these different denominators. And the first denominator I see is 2, then 3, then 4, all the way up to 99 and 100. Okay, so 2 could be my initial value, since that's the first fraction that I see. And the last value I see is 100. So notice that I've said that my control expression is less than or equal to 100, right? We want to go until we reach 100, and we don't want to go past it. And your loop's only going to run while that statement is true. Okay, and we're not skipping any numbers, so we just go with an I++, and it goes from 2 to 3 to 4 and so on. In the body of the loop, there's no need for an if statement. Okay, again, we're not doing anything special with these numbers. We're not saying only take evens, or only take odds, or only take numbers that are prime, or have a factor. So there's no need to ask a question here. All we need to do is start adding these numbers. Now, to add these numbers, I need somewhere to put them. Okay, I'm going to make a variable named sum. I'm going to declare sum to be a double, and the reason I'm declaring it to be a double is that the answer's going to be a double. Okay, and that's pretty obvious if you just look at the fractions. I don't expect this to be an integer answer. 0 is a great value to initialize sum to, because we call that the additive identity. It won't mess up anything here. You can add numbers, you add 0 to something, it doesn't change it. Alright, so all I want to do right here is say take sum and continually add to its value the next fraction. The first fraction is 1 divided by I. Okay, well, gotta be careful. It doesn't matter that I declared sum as a double. If I encounter an integer divided by an integer, and since I is labeled as an integer, this would do integer division. 1/2 would be 0, so would a third, so would a fourth, and so would every other fraction. You would just get 0.0 at the end. I have to change one of these two numbers to be a double. I'll change the numerator to be a double. I could have typecasted I, but this just seems easier to me. Okay. When the loop's finished, again, I don't want to print until I'm all complete here. I want to wait until this whole thing's done. I don't want to try to figure out the answer ahead of time. I'm just going to wait till the loop's finished. Every fraction has been added, and when I run this, there's my answer, a little bit more accurate than my approximation earlier.